Look up at the night sky. On many nights you can see a bright light. It doesn't twinkle like distant stars. That bright light is often Jupiter. It is the fifth planet from our sun, and it is a true giant. Jupiter is named after the king of the Roman gods. This name fits perfectly. It rules over the other planets in many ways. We are just beginning to understand its majesty. Our journey to explore this colossal world is ongoing and full of wonder. Jupiter is not like Earth. You cannot stand on Jupiter. It is a gas giant. This means it is made mostly of gases. Hydrogen and helium are the main ingredients. These are the same light gases that make up our sun. Deep inside, the pressure is immense. So immense it might have a small rocky core, but mostly it's a swirling ball of gas and liquid. Imagine a planet without a solid surface to land on. That's Jupiter for you. A truly different kind of world than our own rocky home. One of Jupiter's most famous features is the Great Red Spot. What is it? It's a gigantic storm, bigger than Earth itself. This storm has been raging for centuries. We know this because astronomers have observed it for at least 300 years. Think about a hurricane on Earth. Now imagine one that lasts for hundreds of years and is wider than our entire planet. This gives you an idea of the power within Jupiter's atmosphere. It's a symbol of Jupiter's dynamic and turbulent nature. Why is Jupiter so fascinating to us? It's more than just a big planet. It's like a miniature solar system. It has many moons. Some are as big as planets. It has rings, though not as famous as Saturn's. Its powerful magnetic field creates amazing auroras. Studying Jupiter helps us understand how solar systems form. It even helps us understand planets around other stars. Jupiter is a key piece in the cosmic puzzle. And there's so much more to discover. Let's talk about size. Jupiter is big. Really, really big. It is the largest planet in our solar system. No contest. If Jupiter were a hollow ball, you could fit more than 1,300 Earths inside it. Think about that for a moment. All the mountains, oceans, and continents of Earth fitting inside Jupiter over 1,000 times. Its mass is more than twice the mass of all other planets in the solar system combined. It truly is a heavyweight champion of our cosmic neighborhood. This immense scale is hard to grasp. This enormous size has profound effects. Jupiter is so massive that it actually produces its own internal heat. It radiates more heat into space than it receives from the distant sun. This internal heat comes from its slow gravitational contraction. It's like the planet is still forming, still settling down. This heat helps drive its wild weather patterns. It fuels those gigantic storms we see. The Great Red Spot is just one example. Jupiter's size makes it an active, energetic world from the inside out. Despite its huge size, Jupiter spins incredibly fast. It completes one rotation in less than 10 Earth hours. That's the shortest day of any planet in our solar system. Imagine a day that's over before your Earth workday even finishes. This rapid spin causes Jupiter to bulge at its equator. It's not perfectly round. It's slightly flattened at the poles. This fast rotation also stretches its clouds into long bands. These colorful bands run parallel to the equator, giving Jupiter its distinctive striped appearance. So, Jupiter's scale is not just a number. It defines its character, its mass, its volume, its internal heat, its fast spin. All these things are connected. They make Jupiter the dynamic and powerful planet it is. It's a world of superlatives. The biggest, the most massive, the fastest spinning, for its size. Understanding this scale helps us appreciate its influence. It helps us see why Jupiter is such a dominant force in our solar system. It challenges our Earth-centric perspective. Gravity. It's the force that keeps your feet on the ground. It keeps Earth orbiting the sun. Every object with mass has gravity. The more mass an object has, the stronger its gravitational pull. Jupiter, being the most massive planet, has incredibly strong gravity. Its gravitational pull is more than twice as strong as Earth's. If you could stand on a platform in Jupiter's atmosphere, you would weigh over 2 times what you weigh on Earth. This powerful grip shapes everything around Jupiter. Jupiter's gravity plays a vital role in our solar system. Some call it a cosmic vacuum cleaner. Its immense gravity helps to sweep up or deflect dangerous space debris. Think of asteroids and comets that might otherwise head towards the inner solar system, including Earth. Jupiter has likely protected Earth from countless impacts over billions of years. It's like a giant guardian, patrolling the outer solar system. We might owe our existence in part to Jupiter's powerful gravitational shield. It's a planetary bodyguard. The asteroid belt, located between Mars and Jupiter, is another example of Jupiter's influence. Astronomers believe that Jupiter's gravity prevented the material in this region from forming a planet. Instead, these rocky bodies just keep orbiting, occasionally bumping into each other. Jupiter's gravity also perturbs the orbits of comets. It can fling them out of the solar system entirely, or it can capture them into orbits around itself. It's a cosmic shepherd, guiding the paths of smaller bodies. This gravitational power also extends to its own family of moons. Jupiter's gravity keeps its many moons locked in orbit, but it's a dynamic relationship. The gravity of Jupiter, combined with the gravity of other moons, creates tidal forces. These forces stretch and squeeze the moons. For some moons, like Io, this tidal heating is incredibly powerful. It melts their insides and fuels intense volcanic activity. Jupiter's gravity isn't just holding things, it's actively shaping them. It's a cosmic sculptor. Jupiter isn't alone on its journey through space. It is accompanied by a vast entourage of moons. As of my latest update in early 2025, we know of nearly 100 moons orbiting Jupiter. That number keeps growing as our telescopes get better. Some are large, like small planets, others are tiny, just a few kilometers across. This diverse collection makes the Jovian system a fascinating place. It's a complex system of worlds orbiting a central giant, a true celestial court. The most famous of Jupiter's moons are the four largest ones. These are Io, Europa, Ganymede, and Callisto. They are called the Galilean moons. Why? Because they were first observed by the astronomer Galileo Galilei in 1610. His simple telescope revealed these pinpricks of light orbiting Jupiter. This was a revolutionary discovery. It showed that not everything in the universe orbited Earth. This supported the idea that Earth was not the center of everything. These four moons are worlds in their own right, each with unique characteristics. Beyond the big four, Jupiter has many smaller moons. These are often irregular in shape. They look more like captured asteroids than perfectly round worlds. Many of them have tilted or eccentric orbits. Some even orbit Jupiter in the opposite direction to its rotation. This suggests they were indeed captured by Jupiter's immense gravity long ago. These smaller moons are like cosmic fossils. They can tell us about the early history of the solar system, and about the conditions when Jupiter was still forming. The entire system of Jupiter and its moons is often called the Jovian system. It truly is like a miniature solar system. You have a central giant, Jupiter, acting like a star, and you have planets, the large moons, and smaller bodies orbiting it. Studying this system helps us understand how planetary systems in general might form and evolve. It's a natural laboratory right in our own backyard. The complexity and diversity within Jupiter's family of moons offer endless opportunities for exploration and discovery. Let's journey to Io, the innermost of Jupiter's large moons. Io is a truly wild place. It's the most volcanically active world in the entire solar system. Its surface is a vibrant canvas of yellows, reds, oranges, and blacks. These colors come from sulfur and sulfur compounds. These materials are constantly spewed out by hundreds of volcanoes. Some of these volcanic plumes shoot hundreds of kilometers into space. Forget peaceful, serene moons. Io is a world of fire and brimstone, constantly reshaping itself. What powers this incredible volcanic activity? It's not internal heat like Earth's volcanoes primarily. The main engine is Jupiter itself. Io is caught in a gravitational tug-of-war. Jupiter pulls strongly on one side. The outer Galilean moons, Europa and Ganymede, pull on the other side. This constant stretching and squeezing generates enormous friction inside Io. This friction heats Io's interior, melting rock into magma. This process is called tidal heating. It's like kneading dough but on a planetary scale, generating immense heat. The material erupted from Io's volcanoes doesn't just fall back to the surface. Much of it escapes Io's weak gravity. It forms a giant donut-shaped cloud of charged particles around Jupiter. This is called the Io plasma torus. This torus interacts with Jupiter's powerful magnetic field. It contributes to Jupiter's intense radiation belts. It also helps create some of the auroras seen near Jupiter's poles. So Io's volcanism has effects far beyond its own surface. It actively feeds Jupiter's magnetosphere. Io is truly unique. It's a dynamic, ever-changing world. Its surface is constantly being repaved by volcanic flows. This means there are very few impact craters. Any craters that form are quickly buried. Studying Io helps us understand extreme geological processes. It shows us how tidal forces can dramatically shape a celestial body. It's a natural laboratory for volcanology. Io reminds us that moons can be just as active and exciting as planets, if not more so. A truly hellish yet fascinating place. Section 6. Europa, the icy enigma and its hidden ocean. Next in line from Jupiter is Europa. At first glance, Europa looks very different from fiery Io. It is covered by a bright, smooth shell of water ice. This icy crust is crisscrossed by long, dark streaks and cracks. These features make it look like a giant cracked eggshell. Unlike heavily cratered moons like our own, Europa has relatively few impact craters. This suggests its surface is young and active. Something is constantly renewing it, resurfacing it, smoothing out the blemishes of cosmic impacts. The most exciting thing about Europa is what might lie beneath its icy shell. Scientists have strong evidence that Europa hides a vast ocean of salty liquid water. This evidence comes from several sources. Data from the Galileo spacecraft showed disruptions in Jupiter's magnetic field around Europa. These disruptions are best explained by a global electrically conductive layer, like a salty ocean. The surface features like the cracks and ridges also suggest a mobile ice shell floating on liquid water below. A liquid water ocean. Think about that. Wherever we find liquid water on Earth, we find life. This makes Europa one of the most compelling places in our solar system to search for extraterrestrial life. The ocean could be tens to over 100 kilometers deep. It could contain more water than all of Earth's oceans combined. If this ocean also has sources of energy and the right chemical ingredients, it could potentially harbor life, not little green men perhaps, but maybe microbial life, hidden from our view. Exploring Europa's ocean is a huge challenge, of course. That ice shell is likely many kilometers thick. Getting through it to sample the water below will require incredible technology, but the potential rewards are immense. Future missions are planned to study Europa in more detail. They will try to confirm the ocean's existence and characteristics. They will look for plumes of water vapor erupting from the surface. Europa remains an icy enigma, beckoning us to uncover its secrets. A truly tantalizing prospect for discovery. Section 7. Ganymede, the solar system's largest moon, a giant's companion. Now let's meet Ganymede. It's not just Jupiter's largest moon, it's the largest moon in our entire solar system. Ganymede is bigger than the planet Mercury. It's even bigger than the dwarf planet Pluto. If Ganymede orbited the Sun on its own, it would definitely be classified as a planet. This moon is a world in its own right, and it holds a unique distinction. Ganymede is the only moon in the solar system known to have its own magnetic field. This suggests a dynamic molten core, much like Earth's. Ganymede's composition is a mix of rock and ice. Scientists believe it has a differentiated structure. This means it has layers, like an onion. It likely has an iron-rich core generating that magnetic field, then a rocky mantle, and then a thick outer shell of ice. Excitingly, there's evidence that Ganymede might also have a subsurface ocean, or even multiple layers of ocean sandwiched between layers of ice. This makes Ganymede another potential candidate for harboring liquid water, though perhaps deeper and less accessible than Europa's. Ganymede's surface is a fascinating mix of old and new terrains. About 1/3 of its surface is dark and heavily cratered. This tells us that these regions are very old, billions of years old. They have been exposed to impacts for a long time. The other 2/3 of the surface are brighter and younger. These areas are marked by complex patterns of grooves and ridges. This grooved terrain suggests that Ganymede experienced periods of tectonic activity in its past. Forces from within stretched and fractured its icy crust. Ganymede is a truly complex and intriguing world. It's not just a big ball of ice and rock, it has its own internal heat source from the decay of radioactive elements in past tidal heating. It has its own magnetic field. It has diverse geology. It might even have a hidden ocean. Studying Ganymede helps us understand how large icy moons form and evolve. It provides another piece in the puzzle of where liquid water and potentially life might exist beyond Earth. A true giant among moons. Section 8. Callisto, the ancient canvas of cosmic history. Our final Galilean moon to visit is Callisto. It is the outermost of the four. Callisto is a bit of an oddball compared to its siblings. Its surface is a testament to billions of years of cosmic history. It is incredibly old and heavily cratered. In fact, it's one of the most heavily cratered surfaces in the entire solar system. This tells us that Callisto has not experienced much geological activity for a very long time. Unlike Io's volcanoes or Europa's resurfacing, Callisto's face remains largely unchanged. This lack of geological activity means Callisto is often described as a dead world, but that might not be entirely fair. Its ancient surface is like a perfectly preserved canvas. It records the history of impacts in the outer solar system. By studying its craters, scientists can learn about the population of comets and asteroids over billions of years. Callisto's interior is also thought to be less differentiated than Ganymede's. It may not have fully separated into distinct layers of rock and ice. It's more of a mixed bag. Despite its seemingly inactive surface, Callisto might still hold a surprise. There is some evidence, though less conclusive than for Europa or Ganymede, that Callisto could have a subsurface ocean. If it exists, this ocean would be very deep beneath the icy crust. It would also be surrounded by ice rather than in contact with a rocky mantle like Europa's might be. This could make it less geochemically rich. However, the mere possibility of liquid water keeps Callisto on the list of interesting places to study. Callisto serves as a valuable reference point. Its ancient, battered surface contrasts sharply with the dynamic surfaces of the other Galilean moons. This comparison helps us understand the different evolutionary paths these worlds have taken. It highlights the diverse effects of tidal heating and internal processes. Callisto is a quiet witness to the solar system's long and often violent history. It's a time capsule, patiently waiting for us to read its stories written in impact craters. A silent historian of the cosmos. Section 9. Journey to Jupiter. Probing the giant and its secrets. Our understanding of Jupiter and its moons hasn't come easily. It's the result of decades of dedicated scientific missions. The first spacecraft to visit Jupiter were NASA's Pioneer 10 and 11 in the 1970s. They gave us our first close-up glimpses. Then came the Voyager 1 and 2 missions. They provided stunning images and a wealth of data. They discovered Io's volcanoes and hints of Europa's ocean. Later, the Galileo spacecraft orbited Jupiter for nearly 8 years. It studied the planet and its moons in unprecedented detail. More recently, NASA's Juno spacecraft has been revolutionizing our view of Jupiter. Launched in 2011, Juno arrived at Jupiter in 2016. Its mission is to understand Jupiter's origin and evolution. Juno orbits Jupiter in a highly elliptical path, swooping close over its poles. It is studying Jupiter's atmosphere, its deep structure, its gravity, and its powerful magnetic field. Juno has sent back breathtaking images of Jupiter's poles. It has revealed that Jupiter's auroras are the most powerful in the solar system, and that its atmospheric dynamics are even more complex than we thought. Juno's discoveries are ongoing. We've learned about shallow lightning in Jupiter's atmosphere, different from Earth's. We've found that the ammonia in its atmosphere behaves in unexpected ways. The Great Red Spot, we've learned, is incredibly deep, extending far below the cloud tops. Juno is also helping us understand Jupiter's core. Is it a distinct solid core or more of a fuzzy, diluted one? These are key questions Juno is helping to answer. Each orbit brings new data, new insights, and often new puzzles. The exploration of the Jovian system is far from over. Future missions are already planned or underway. NASA's Europa Clipper mission is designed to make detailed reconnaissance of Europa. It will investigate its ice shell, its ocean, and its potential habitability. The European Space Agency's JUICE mission, Jupiter Icy Moons Explorer, will study Ganymede, Callisto, and Europa. It will culminate in orbiting Ganymede. Studying Jupiter and its moons is crucial. It helps us understand not just our solar system but also the thousands of giant planets now being discovered around other stars. The journey continues.